Welcome back to School of Civil Engineering. As we have started a very interesting YouTube tutorial series about quick machinery, quick footing, quick concrete wall, and quick retaining wall design by using that software. So in this software we're using, in this tutorial we're using uh, Quick Suite software version 4, and it's ESI software. So I think it will be very helpful tutorial for you. So in our previous video I have shown you about that how we will understand about that software. Basic introduction. I have discussed about basic introduction of that software. So in this video I'm going to discuss about a beam design. So how we'll design a beam within a minute. So how we'll design that, I will show you about that. So let's start. So first of all we'll use our quick machinery software like as previous, and from here we'll select beam, and from here beam 1. Okay, then it's done. After that we have to go here criteria, and from here we'll building code, we'll select any of it. So we'll use the latest one, MJ MSJC 11 ASD, and here our load combination, which is IBC code or ASC code. I will select ASC 10 ASD. Then this the seismic R value. What will be the seismic R value? You can give here your seismic R value. Then here is the seismic response modification factor. Okay, so you have to give here the seismic modification factor according to your code. And okay, suppose if we give here for beam 5, done. Then here materials property, will give the materials property, and here I will give the 2500 psi. Okay, 2.5 ksi compressive strength, and Fy the yield strength. Yield strength is 600 psi. Okay, done. Then average unit weight of our materials, I will give here 150. So 150. And after that here exposed to earth or weather, if exposed to earth or weather, you have to take here the take share at d by 2 from support d by 2. D is the effective depth of the beam, so I will take it yes. And you can read that, and also you should read that for every option what is working for hot. And okay, our criteria is done. Then we'll go for load. So here uh, we'll give the loads. So first of all I will click here add load. So from here for add load, they have the load name. So first of all dead load. So for dead load you have to click from select from here dead load, and after that distributed load. So what will be the distributed load? So that as this is a uniformly distributed load, so I'll give her the uniformly distributed load. Suppose if I consider 100 pound, you can give here according to code distribution load, and the out of plane offset P. So we'll not give anything here. Then concentrate load, here we'll go give here the point loads. Suppose they have no point loads. Okay, and here you're seeing that from that point to that point the loads are working on our beam. Okay, so also they have option out of plane uniform. Okay, so if you give here out of plane uniform, so this is not a plane uniform, so you can give here value according to it. And after that I know that for a beam design concentrate load is not required, but if you want to give any concentrate load, so you can give here. And here is the, suppose I will give the concentrate load 1 kip, and my distance will be here from that point to that point. What will be the beam distance? Okay, so I will not give that. Okay, so 00, then press okay. This is the uniformly distributed for distributed load for live load. And actually before that, okay, let's add the load, then I'm showing you. Then we'll select live load, click here LL, then from here live load will be live load, suppose 80 pound per feet. So then click OK. Then here is our to load. after that go here beam. Actually before assigning load, we should come here beam, and first of all clear span. What is the clear span? From one support to another support, what is the clear span? So suppose I will consider this is 15 feet, 15 feet, and after that here it's showing effective span. We'll click effective span here, uh, given calculate or specify. If you want to specify, you can specify that, or otherwise you can calculate that. Okay, so it will the software will calculate according to the code. So I think it's better to use calculate than here effective span build integrally with support. Then click here the depth. What is the depth of our, here is the depth. What is the depth of our beam? So I'll consider it its depth is 18 inch. Okay, so height of wall above. So suppose if there have any height wall, if there have any wall above that beam, so you can also give its value here, then get a dimension from what is the block size. Okay, also you can give it here. Then after that here is the block size. Okay, so you can also specify that here is the block size. You can specify that from here. The overall thickness, what will be the overall thickness? Here is the overall thickness 8 inch. Okay, overall thickness is 8 inch. Then here effective thickness, it's also given 8 inch. Then face has given the face shell thickness, you can give 1 inch, and if you give 0 also, sorry, it can be 0. Face shell thickness, that value, for that value. So I will give that leave it 1. Okay, done. It's also 1 inch. Then specify out of plane span. Okay, specify out of plane trajectory height. Okay, done. Then bond type here, you can click here bond type. After that mortar type. Okay, after that depth to the here, depth to the load level, you can give the depth to load level. You can also give it here applied at load, applied at load location. So after that flexural, you can give it the flexural reinforcement. So reverse size, which size bar will use? The reverse size I will use number 4 bar. And after that row of bar, which row? There have one row. Okay, so row of bar you can give here 2. If you give here 2, then just see that here is the 2 row of bar. So row of bar 1. Okay, so here bar per row 2, bar per row 2. You can also increase that, it's 3 4 6 7 8 anything. Then clear cover, what is the clear cover? Just consider it's 2 inch. If you select 1 inch, so it will be very close to it. So use clear cover, sorry, here use clear cover 2 inch. Then strap size, what will be the strap size? Here is the strap size, suppose number 3 bar will use for strap. And here strap are sample Lux, so if you use that for one side, you can use that. So untick it here. Now just see one thing, suppose if we use number 3 bar, it will also okay. For here, just if you see here, it's also okay, but we'll use number 4 bar. Okay, and now if I give here a height of the wall, suppose there have a sorry, there is 5 feet wall. Then see here, then two portion have been failed, the flexure and the deflection. Okay, deflection fail also, and the flexure fail. So for that when we'll give here, we have to increase the beam thickness, it's 8 inch. I will give here, so block size, it's 8 inch. Specified, I'll give her 10 inch. effective thickness also 10 inch, and it's done. So again it's not okay. So if we increase the depth 18 inch, if we use 24 inch, just see our deflection is okay, but our flexure is not okay. So for that, if we increase the bar size number 5 bar, just see that it's okay now. So just see how easy it is. Okay, how easy it is to design that. So our design is okay, our design is okay. Now we'll get the design report for it. Okay, so for that we'll click here, just on click here, print, and here name Adobe PDF, and it will copy as a PDF file. So you can also select another. I will select as a PDF, then wall, print wall, then place here OK. After that click here in bottom. So after that you have to select the location where PDF. Suppose I'll selecting in desktop. So after that it's working. PDF have been created. So if I come here and if I see that our number 4 page PDF are ready. So courtesy of here the given level 1 free for wall, and here just see that this is our cross section of our beam. Here is the number of bar provided, here is the size, and here is the thickness. So just see here, this is also giving you the wall data according to ASCE or according to anything. It's giving you everything here. So here is our load, and here is our above wall load. So this is the bending moment and shear force for it. So if we go down, so just see that in this way you can design a simply beam. I mean you can design a beam with I mean masonry beam. So I think it's clear to you, and if you have any problem or if you have any question, you can contact me. I will try to cover that, and I will try to give you that solution. So thank you very much. Stay connected to next video, and if you are a civil engineer, then don't forget to subscribe to our channel, and also like our video and share and leave a comment. Your own share, your own like inspires for the next work. So thank you very much. Stay connected till next video.